All right, hi everyone. We're going to look at today solving more complex quadratic equations. Now, the very important skill that we will apply here is really what we call substitution. All right, we usually want to substitute a more complex, usually non-quadratic looking equation into a quadratic equation. All right, so we have to be creative in how we want to substitute. All right, so let's look at example 1. Now we have 4x4 minus 7x squared plus 4 equals to 0. Now this is definitely not a quadratic equation, but we can always transform it into a quadratic equation. And how do we do that? We want to first replace out at least a more complicated part, in this case the x4 and the x squared. So what I'll do is I'll let y be x squared. So this allows me to substitute the x squared out, so I end up having 4y squared, because x4 is like sound like x squared square. All right, so 4y squared minus 17y plus 4 equals to 0. Now this looks like a usual quadratic, right? And we can actually factorize that quite quickly. We'll end up having something like 4y minus 1 and y minus 4 equals to 0. All right, so from here we can kind of solve it. And can kind of solve for what y is. So y equals a quarter and y is equals to 4. Now, we're not actually done in this case. Remember, we're not really solving for y. Y is just to help us, right? We have to solve for x. So what we're going to do here, we're going to replace back y with x squared. And y is equal, x squared equals to 4. Now from here, we will square root, and that will help us to solve for x. Now be careful, when we square root anything, we must have a plus and minus, right? Plus and minus square root 4. So our final answer is plus minus half and plus minus 2. All right, so that's how we actually solve by using substitution. Now, you will notice that every questions here are all the same strategy. We just use substitution very, very often. Now, in this case, what do we substitute here? So, again, we don't really like the x to the power of 1/3. Let's get rid of that. So, we let y be equals to x to the power of 1/3. So, if we're going to substitute that in, so we're going to have 3y squared minus 5y plus 2 equals to 0. Okay. Now, from here, we can factorize it as per usual, because this looks like quadratic. So 3y minus 2, y minus 1 equals to 0. And we go ahead and solve for y. So y equals to 2/3 and y equals to 1. Now, we're not done yet again, because we are trying to solve for x. So let's replace our y out. So x 1/3 equals to 2/3 and x 1/3 equals to 1. And in order to get rid of the 1/3 power, we're going to cube both sides. So this will be 2/3 cube, and this is x equals to 1 cube. All right, so our x will end up being 8/27, and x equals to 1. All right, so we end up being able to solve this equation, and this are our x values. So again, the same strategy applies, which is substitution itself. Okay, now this one looks like, oh, quite complicated. There's no square, right? What do we substitute? Actually, we still can substitute. In this case, we're going to get rid of the square root of x, which is very complicated, right? So we let y be equals to x to the power of half, which essentially is square root of x, right? So when we replace that, notice that if I square both sides, so y squared equals to x. So we're going to use that to replace this. All right, so two things we're going to replace. So x will end up becoming y squared. 4 root x becomes 4y minus 21 equals to 0. Now, from here is the same strategy. We want to factorize that. So y minus 7, y minus 7, y plus 3 equals to 0. And we will end up solving for y equals to 7 and y equals to negative 3. So what we will do next, we're going to replace our y out. So x to the power half is 7 x to the power of half is negative 3. We're going to get rid of the power half by squaring both sides. So this will be 49, and this will become 9 itself, right? Now, but the problem is, if we want to square both sides, think about this scenario. I'm wondering if this is really true. So if square root of x is minus 3, think about it, is it even possible? The reason, because when you square root any number, it will never get you a negative. It's always positive. So this is actually not really true. Okay, so we may think that 9 is an answer, but actually it is not really true. So what we will end up is we're going to end up rejecting this. We're going to say NA. So our final answer is just x equals to 49. All right, so we have to be careful to choose whether answers can be used or not, right? So we have to be really careful. Okay, now let's try example 4. Now, what do we want to replace? In this case, we're going to look at probably 2x, right? We don't want that out. So we're going to let y be equals to 2 power x. And if we replace it, we will end up having 8 2x squared, right? Minus 33 2x plus 4 equals to 0. So we're going to end up having 8y squared minus 33y plus 4 equals to 0. We can factorize y. What will we have? 8y minus 1, and we have y minus 4 equals to 0. And we can solve for y. So y is 1, 8, and y is equals to 4. And now we can replace back, right? 2x equals to 1 over 8. 2x equals to 4. Now we can transform this into 2 to the power of minus 3. And this is 2 to the power of 2. Okay, and our final answer is x equals to minus 3 and x equals to 2. Just by equating the powers together. All right, so I hope these 4 examples are useful to guide you through the process on how to solve more complex quadratic equation by really using the main star of this type of question. The main star is the method of substitution. All right, so we have to choose the correct substitution. We have to be creative sometimes, and then let us be able to substitute it, form a normal quadratic equation, and then we can solve and replace back. All right, so I hope that's clear, and I'll see you in the next one. Cheers.